We'll take our quick look at the calendar. Just finished test number 2. Today we start a brand new section. You can see we're here in chapter 3 for a while and then chapter 4. General themes, looking at all those words over there. Quadratic functions today. The next few classes, polynomial, 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 polynomial. And in fact, quadratics are also polynomials. We'll talk about them, but this is our polynomial theme of the course. Coming up after that, we've got a couple of days on rational functions, a couple of days on exponential functions, a couple of days on log functions, and then our third test will be here before you know it. So the thread for the next few weeks for us is just a few different kinds of functions. But again, the word function is one that we'll use all semester. I will hand out project number 3 next class is not going to be due until November 14, just a heads up. And also speaking of the calendar, well, what's happening tomorrow? Advising day. So hopefully you've got an appointment to meet with your advisor tomorrow or sometime after tomorrow if tomorrow doesn't work for you. But just a reminder, there are no day or evening classes tomorrow, because we want folks to be available to come in and get registered for the spring or summer. Also, the Math Studio will be unlocked tomorrow, but it will not be covered by math faculty according to the usual schedule. So just know that ahead of time. What is available tomorrow, if you're looking for some math or other class assistance, is peer tutoring by appointment. Might be a good day to come in and get a lot of work done if it fits your schedule. Any questions about the calendar? Okay. Then let's take a look. You can skip right past page 1. We'll start together on page 2. And again, the basic idea for today was this thing called a quadratic function. I think it's stuff that you've seen before, although maybe not with function notation. So standard form of a quadratic function is this thing. It's f of x equals a parentheses x minus h squared plus k. Ax minus h squared plus k. And this is supposed to remind us of maybe the original quadratic function, the most basic one we could have, g of x equals x squared. And so we've studied transformations before. So what kinds of transformations have happened going from the original x squared to this more complicated version of things? Ivy.
Horizontal shift, the vertical shift, and the something's happened, and depending on if a is greater than 1 or less, it says shrinkage or stretch.
Let's get one more word, horizontal or vertical. Yeah, that number in the front is a vertical. Good. So a vertical shrink or stretch. Ivy nailed it exactly based on whether a is, bigger than 1 or between 0 and 1. Okay, so all we're doing is stuff that we've seen before. Take your basic parabola x squared and then shift it and stretch it according to this. So in the box here, it says, what can we tell about a parabola, the graph of this new complicated thing, by looking at our standard form? All right, so you guys know the word vertex, right? So you got a parabola there. The vertex is the bottom point on this parabola. So that guy right there, vertex. And it turns out it's pretty darn easy to identify the vertex if you're given this equation in standard form, because we know that the horizontal shift is just going to move us left or right, h, yeah? And then the vertical shift is going to move us up or down, k, and however far we move left, right, or up, down is exactly what's happened to the vertex, because before we do anything, the vertex is right there, right? And so h and k is just where the new vertex is, right? Left, right, up, down. So that's what it says here. It says standard form is convenient because it immediately identifies the vertex as h, comma, k. That h and that k. There's a little twist in there. I mean, you can see there's a minus sign in the parentheses, but a plus sign outside the parentheses. I don't know. It's not a detail that I get lost in. I don't much care what those signs are, but I need you to be able to identify the vertex by looking at a particular equation. So if I said negative 3 x plus 5 squared minus 2, what I need you to know is what the coordinates of the vertex are. Okay, so let's think about it. Forget about the minuses and pluses in that little formula over there. That plus 5, is that right 2 or left 2? Oh, sorry, that right, left, yeah, this is left 5, yes? So what is the x-coordinate of the new vertex? Is -5, comma, that -2, up or down 2? That is down 2, so what's the y-coordinate? Is -2, okay? And so you can see there's a little bit of asymmetry here. The -2 just got copied, but the +5 became -5. And that's like we're trying to sort of get at that by putting that minus sign in the parentheses. Say, hey, remember anything inside is opposite, the opposite direction of what you'd expect, okay? All right, leading coefficient is A. It says a leading coefficient is always the same in general and standard form. Just to remind you, general form was this ax squared plus bx plus c. So those are the two basic forms we're going to be playing with in this section. And it's the same A in both cases. If A is greater than 0, which way does the parabola open? Opens up. And if A is less than 0, down. Up there, down there. Okay, and if the absolute value of that magic number A is big, then the parabola gets, it says narrow here, actually don't, that's the way I think of it, but honestly that's not the way we've been thinking about it this semester together. We said that A was a vertical shrink or stretch, right? So if A is really big, what happens to this? It stretches vertically. So narrower is how I think of it, but in practice this semester, I've been trying to force you to think of it as being taller, right? That A is definitely a vertical transformation. And then it says smaller values make the parabola wider. Again, that's not the word I've been encouraging you to use. Compressed, or yeah, it's a shrink, or maybe the word shorter. I mean, we haven't used the word shorter, but that's how the graph will appear. Okay, so let's move on to number 2, which talks about how we changed from form, the ax squared plus bx plus c form, into our standard form, the ax minus h squared plus k. So these are all going to be numbers, and we're going to try to go from one form to the other. So it says the a in both forms is the same, so that part is easy. Now we just need to identify the h and the k, and we'll have everything we need to write the standard form. Let's just give you an example to be really concrete here. F of x equals, what was the example we made up above? Anybody still have that? Oh, I gave it to you in parentheses already. All right, scratch that. -2 x squared plus 12x minus 5. Let's try that. So given that equation, I'd really like us to be able to write it in our standard form equation with the x minus h in the parentheses squared, and then a plus some number at the end. That's the goal, okay? And so the question is, how much is the h and how much is the k? And it turns out there's a pretty nifty little formula that will find it for us. So let me put here the goal. The goal is to rewrite that same f of x It's like some freaky Halloween stuff happening on my smartboard today. Like it's just right, and it's like orange and black, which is like the I'm not sure what's going on. Equals ax minus h squared plus k. Okay, that's the goal. All right. The a is easy. How much is the a? It's -2. It's the same a from up above. So that part is no problem. But the part that we got to work on is the h and the k. But like I said, there's an easy way to get this if you know the magic formula. So here's the magic formula. It says the vertex of a parabola of the form ax squared plus bx plus c is given by, I'm just going to focus on this x coordinate first. It says the x coordinate of the vertex is -b over 2a. Might be a formula you've seen before. You might have seen this vertex formula before. For sure, you have seen the quadratic formula before. -b, oops. -b plus or minus square root, not going to write all that, over 2a. Right? Quadratic formula. Do you see the -b over 2a sitting right there? Right? Like if you just ignore the plus or minus, all that stuff is nothing. And it's even an x equals, right? The quadratic formula is x equals, and that's the x coordinate. So you've seen the -b over 2a embedded in the quadratic formula. And once you know the x coordinate, well, finding the y is just a matter of plugging the x into the formula, right, into the f of x equation. So that's the second part, is just plug in the x that you know into the formula. So let's give it a shot here. So in our case, the x, I'm going to introduce some new notation here. X equals, so I'm going to call it x sub v for the x coordinate of the vertex. So it's our same negative b over 2a. So negative, how much is the b? 12, that's the b right there in the middle. Whoops, it's negative 12 over 2 times a. 2 times what number? Negative 2, good. So we just crunch that through and we get the x coordinate of the vertex is 3. And again, going back to the blue equation, how would you find the y when x is 3? Just plug the 3 in, right? So it's just finding f of 3. And so this thing highlighted here in blue, it looks complicated, but it just says plug the 3 in. You find the x and then you plug it in. So let's find the y coordinate here. The y coordinate, again, I'll put a little subscript of v. So we know it's the vertex. The y coordinate of the vertex is f of 3, which we can plug in 3 for all these x's up here. Negative 2 times 3 squared plus 12 times 3 minus 5. I heard a vote for 13. Is that right? Positive 13. So that's a negative 18 over negative 18 plus 36 there minus 5. Okay, so putting these two things together, we just identified our vertex. X is 3, y is 13. 3 comma 13. Okay. And so remember, the goal was here in orange was to rewrite our original function, but in this magical standard form with the h and the k. So we did all the hard work to find the h and k. We just have to copy it. So here it is. F of x equals, all right, so the a in the front is the same a as negative 2. X, and then something squared here. And then plus some number at the end there. Okay, so we know the vertex is supposed to happen when x is 3. It's either going to be a plus 3 or a minus 3. I don't want you to get it wrong. And I don't want you to think about the formula that had x minus h in it. That formula is not all that helpful, honestly. Yeah, just think you got to move the vertex to x equals 3 and up 13, right? 3 to the right is minus 3. 3 comma 13. Is it plus 13 or minus 13? Plus 13. Okay, so that's how we convert from, we started with the blue, that's standard, the general form, and then got it down here with our fancy vertex formulas. All right, and I don't want to freak anybody out, but today is Halloween, right? And 13 is kind of an unlucky number for a lot of people, and Halloween is not, right? And if you do 13 backwards, it's 31, October 30. And I'm telling, I just made this thing up. I wasn't planning. I just made it up. And there, 1331. All right, next page. Okay, so okay, so number 3 up here, I'm just going to change to the problem that we did. Can somebody remind me? It was negative 2x squared plus 12 minus 5. Okay, so we're most of the way through filling this thing in, but for a problem that I just made up. So let's try this one instead. Okay, so we'll go ahead and copy our stuff from the previous page. The vertex we found already is 313. Standard form was the last thing we wrote. -2 x minus 3 squared plus 13. I'm changing this problem so that just because we've already done all the work. I just made one up. So we'll do that. We'll do the one we made up instead of this one on the page. Okay, does this parabola open up or down? Opens down because that -2 is a negative number, right? So we say down since a was -2 and that is less than 0. It's a negative number. Okay, and you know, the third test is a long way away, so I haven't really thought about it much, but I see this pretty often, and so I'm just going to put it out there. If instead you wrote since ax squared was negative, that's not quite it. I think that's losing a point there for that explanation. It's just the a value. It has nothing to do with the x or the x squared. Okay, it's just about the value of a. So don't put ax squared, and don't put -2x squared or -2x squared. It's just about the -2. It's just the a. Okay, all right, so here's something we haven't done yet, finding the y-intercept. Okay, so finding the y-intercept of any function involves setting what variable to what number? X to 0. Okay, so we just have to find f of 0. Okay, we have two different versions of f up on the board. They're both equivalent. One of them is good for some things, the other is good for other things. Plugging x equals 0 into the purple involves doing a little bit of arithmetic. Agree? 0 minus 3, that's -3. You square it, 9, 18 plus -18 plus 13 is -5. It's fine. It's the right answer. But plugging 0 into the blue, it's a whole heck of a lot easier. Yes? What do you get when you plug 0 into the blue? -5, right? So like you can, doesn't matter which one you use, but recognize that the y-intercept is that c value sitting at the end. Okay, so then it says find the x-intercepts of the parabola, if any. Okay, so let's give this a shot. Okay, so to find x-intercepts, in general, we set what to what? We set y to 0. Okay, again, you've got two choices here, blue or purple. I'm going to go to blue. Purple could be perfectly good. I'm going to go to blue. So let's set the y equal to 0 in blue. That means 0 equals all of that stuff. Okay, so finding the x-intercepts is a lot harder than finding the y-intercepts. What's the technique here? Factor. If the thing factors, that's the way to go. You guys remember the factoring idea, right? Two sets of parentheses. That wasn't the answer I was looking for there. Two sets of parentheses. We're trying to fill in the stuff in the blank. Some of you did a lot of this factoring in 096 by using a 2x2 box, right? Or you could do trial and error. There are different options. Is it guaranteed this is going to factor? No. In fact, if a certain math teacher just made this up, not thinking ahead, would you say it's likely or not likely that it factors? It is unlikely that it factors. Yeah. Sorry about that. So the only option we have if it doesn't factor is the quadratic formula. So that's what we do. Okay, quadratic formula. For what it's worth, the original problem that was typed on the top of the page also doesn't factor. So we would have had to do this anyway, but I like thinking of factoring first. But quadratic formula, let's try it. So -b negative 12 plus or minus the square root of b squared, 12 squared minus 4 times negative 2 times negative 5. All divided by 2 times negative 2. Notice my abundant use of parentheses. You didn't need as many parentheses as I put, but sometimes you do, and it's better to have too many than too few. Okay, let's crunch all this through. Negative 12 plus or minus square root of, can somebody get us just a single number here? That's 144, and then it's going to be a minus, we'll just put it 144 minus 40, and then that's divided by negative 4. So square root of 104 over negative 4. I think that's fine. It is possible to reduce that square root of 104. What perfect square goes into 104? Perfect square that divides evenly into 104. The perfect squares are the bottom row of these yellow numbers up here. So you have to ask yourself, does 4 go into 104? Does 9 go in? Does 16 go in? Which one goes in? Yeah, 4 goes in. But given that we're going to need, so like graphing the square root of 104 on the axes here is not something I can do. So since we're going to go to the calculator at some point anyway, I'm tempted to just go there now. So very carefully on the calculator, we're typing this in. Negative 12 plus the square root of 104. It's okay if you don't have a calculator on you. Divided by negative 4. All right, I made a number of mistakes here. Okay, so we got to close the parentheses here because the calculator thought it was smarter than me and put parentheses when I didn't ask for it. But now I made a really easy mistake to make that's less obvious. Yeah, how do I make it so the whole thing is... Yeah, it's really easy to forget that you need to do these extra parentheses here around the whole numerator. Because when you write it, it's obvious the whole thing is upstairs because we got this big fraction line, but the calculator doesn't know that. So we got to do this. Okay, so 0.45 is one answer. What small change do I make to get the other answer? Just minus instead of plus. And so it's actually pretty quick to type them both into the calculator if you type it in one shot like I did up there, but that means extra parentheses. Okay, so we've got our answers here. We'll just go to the nearest hundredth. So this is roughly 0.45 or 5.55. Okay, so I think we've got enough information here to plot all of our points. Let's be explicit with the y-intercept. What, comma, what? 0, negative 5. That one's easy, okay, it's just written that way. Let's also be explicit down here with our x-intercepts. What, comma, what? That's it, right? Because the first thing we did was make the y equal to 0. And then the other one, 5.55, comma, 0. Okay, so I think we've got enough information. We just plot all of our points and draw a parabola. Let's give it a shot. Okay, we said that the color we're going to do here. Let's go there. Okay, we said 0, negative 5. We'll put a point down there. We've got two x-intercepts. 0.450, just ballpark it. It's not going to be perfect. And then 5.550, 5.55, maybe there. With those 3 points, some students have trouble envisioning any parabola that's going to hit them. Really, if you're looking at this not the right way, it's possible to think that there's no parabola that's going to hit. If you're trying to force an upward opening parabola onto those points, It's not going to happen, right? You might think you've made a mistake here, but this was not an upward opening parabola, right? This is a downward opening parabola. And as soon as you change that perspective in your head, no problem. I can see a parabola opening down that hits all these. What's the only other point we're going to plot? Vertex, which was 313. So we go to 3 up to 13, way up there. I think that's good. If you took 096 recently, your 096 teacher might have said, put the symmetric point to the y-intercept. Right, like there's this vertical line of symmetry, and every point has a partner on the other side of that line. So like 0, -5, where's the partner? How far did we have to go? 6. Yeah, we had to go 3 to get to the vertex. Yes. So I think if we just go 3 more, so come out here to 6, and it's at the same height. So there's a point right there, which you kind of get for free. You just have to think about the symmetry. Okay, and then you carefully draw your parabola. All right, so there's not too many ways that you're going to lose points after you've got those, but for drawing the parabola, but there are 2 things that I do not want to see when you draw your parabola. One of them is this. Parabolas are curvy. Parabola is not 2 straight lines, so don't do that. And then the other thing that I don't want to see is this. That's curvy. What's the problem? Yeah, it doesn't extend. Parabola doesn't just stop because we stopped plotting points, right? So just make sure it extends. I'm not so picky about like having arrows at the bottom. Put them if you want. I'm not going to take points off if you don't. But if you stop because you ran out of points that you plotted, I am going to take points off there. Right? Parabola doesn't care about you or your points, so go farther. Okay. All right, and then one last piece here, and then we'll do the thing on the next page. It says, how would you change the function back into polynomial form? So it's kind of silly because we already have it, but suppose that the first thing, the only thing I gave you here was this, and I wanted it to get back in that blue form, but I didn't tell you the blue thing. I just told you purple. What would you do to purple to turn it back into blue? So I don't think we're solving this equation for something. So we're not moving the 13 over. What would you do? I think that's, it sounded kind of like what Aaron was talking about, by moving the 13 over, and maybe. What would you do with the parentheses? Couldn't we multiply the parentheses out? So -2 there, x minus 3, x minus 3. Just writing 2 of them might help us see how to distribute. Foil or lobster claw, or however you distribute, right? And if you distribute through the parentheses, and then just combine like terms, I think we'll get back to blue. Let's try it. There's a -2 sitting outside. When I do the first, what do I get? X squared. Outers, -3x. Inners, another -3x. Let's smush them together. -6x. Less, +9. It's good. And then copying this +13 here. So all we've done is distributed that square. What's the next algebra thing to do here? Is that -2 can come in. So let's do that. All right, so -2 distributes -2x squared, and then plus, yeah, make sure we get that +12x, and then -18 there, and then +13 there. And that's the blue, right? Yeah, so we can go either direction. If I give you the blue, we use our fancy new Vertex formula, the -b/2a. But if I give you purple, it's just a lot of distributing and combining like terms, right? So either direction, with just a little bit of practice, we can go. Questions on that? The +13 is sitting at the end, so it's just copied up here. And then I got a, yeah, -18. Good. Okay, next page. I think this is the last part of the demo. So far, we've been given an equation and we drew the graph. That's what we just spent a bunch of time doing. We're going to try to go the other direction to right here. So in number 5, I'm giving you the graph and I'm asking you to find what? Find an equation. So let's find an equation. Okay, I'm going to write down our two formulas here. X minus h squared plus k, I think. Okay, can we look at the parabola and know anything about the value of a? So the up 5 makes the a positive? Yeah, the parabola opening upward means that a is positive. But I can't look at this right now and say, oh, a is positive 2 or a is positive 3.6, right? So it's hard to look at a graph and decide what a is. What about the b? Have we said anything about looking at the graph and figuring out the b? We haven't. And honestly, I don't know anything about that either. What about the c? Can you look at the graph and determine the c? You can. What is c? It's 23, because we saw on the previous example that the y-intercept just turned out to be this value of c here. Okay, great. So we got one thing. We got that the c is 23. That's from the y-intercept. But we kind of struck out on the a and the b. Let's look at the other equation. Maybe we'll have some more luck starting with that one. The a, I still don't know anything other than it's positive. H and k, how do you see them from the graph? That's the vertex, right? The h and the k are the vertex. We just got both of them. So let's fill them in. Y equals a times x something squared. Okay, the vertex, the x coordinate was how much? 3. And is that going to be an x plus 3 or an x minus 3? Minus 3, because we got to go to the right. Minus 3. Okay, how much is the k? It's 5. And we had to go up from the origin to get to this new vertex. Plus 5. Okay, good. So in the first equation with the ABC, we only got c. But in the second equation, we got h and k. So we still have work to do, but I'd rather work from the second equation where the only unknown is the a, which is left over, okay? All right, so let's give this a shot. All we've used in this bottom purple equation is the 3, 5. We have not used the 6, 23 or the 0, 23. I think we could use either one. More often, we're going to be given a y-intercept than a random point out there, so let's use this y-intercept. Here we go. How much is the y at that point? 23 equals a. I don't know, but I'm about to find it. How much is the x at that point? 0. Great. Copy everything else. And then rejoice as soon as you see that we have enough information to find a, right? I don't see a lot of rejoicing in this room. Yeah. Pretend rejoicing is good enough. Did I do that right? I got 2. It's okay? Yeah, subtract the 5 and then divide by the 9. Okay, so a is 2. So that means that we're ready to rewrite our purple equation in its final form. I'm going to go back to our f of x notation instead of the y notation. Okay, so the first thing was a. We saw it was 2. Copying everything else, x minus 3 squared plus 5. Okay, so there are a number of different things I want you to be able to do with parabolas and their equations. I'm not a fan of memorizing, and I'm not a fan of memorizing here. So I wouldn't try to get like an explicit list of, oh, if he gives me the standard form and he wants the general form, here's the process. In the other direction, here's the process. And given the graph, here's the process. I wouldn't do any of that. I'd just practice and start to kind of think about general themes and what information do I have and how can I use that information to get what I want. I think that's more useful than having a list of a number of different processes. Okay, any questions? Okay, activity starts on the next page. Raise a flag if I can help.